Hello everyone. I hope you guys are safe, healthy, no issues. So it was very unfortunate that we had to cut it short related to topics which we are covering in electromagnetic fields and waves. So what I've done is I'll be posting some videos and we'll try to cover it offline. I mean through YouTube videos. Uh, so the thing is, I'll be starting off with like magnetostatics first. So I had already covered the electrostatics part. So now I had started with magnetostatics, but let's just start again through this video lectures. So I'll be covering Biot-Savart law first, then the Ampere's law, and as we go along, we'll be solving some problems. So I'll be giving you some exercises. So what we can do is I'll solve those exercises also through videos. If you have any specific problem to be solved, you can just WhatsApp me, and then I'll take it up. I'll not be able to take everybody's request, but you guys on your own can at least select one or two problems related to each topic, and we can solve it. Okay. So right now, what we'll do is we'll start with magnetostatics. Okay. What I'll be starting off with is magnetostatics, which will involve Biot-Savart law, which is very similar to Coulomb's law, okay, which we had covered in electrostatics. So what exactly happens here is you were using Coulomb's law for finding the electrostatic field intensity, right? You are using this to find out E. E was, if your what is E? E is equal to force upon charge. That is what we had studied, force upon charge. And how is this force generated? So if you keep any charge in space, it is stationary. Okay, stationary. Then what happens is it generates some force at the point surrounding it, right? The space surrounding it. So that force divided by the unit charge. So how do we measure that? What we do is we get a very small point charge near it. So let's say I want to find out the electric field intensity at this point. So what I'll do is I'll get a charge, a very small test charge, which is always considered to be a positive charge. Okay, for our explanation. So we always get a positive charge, place it there. So how much of a force this charge is exerting on this point charge or test charge? This is a test charge divided by the test charge. We get a positive test charge here, place it here, and how much of a force is exerted by this charge divided by the test charge is your electric field intensity. The same way, Biot-Savart law is very similar to Coulomb's law. Only thing is here it is telling you to it helps you in finding out the magnetic field intensity, H. Okay, so that we will see. Now we had studied Gauss's law in Gauss's law. Why we had used Gauss's law was we know that in some cases it becomes difficult to solve the integrations, right? Integration in your when you're trying to find out the electric field intensity at any point using Coulomb's law. Sometimes you have to solve complex integrations. So in that case, in those cases, sometimes the Gauss's law helps you. This Gauss's law helps you. Very similar to that, you have something called as Ampere's law. Ampere's law in magnetostatics, which will again help you to find out H, because your Biot-Savart law is again about integration. So hence this helps you to find out the magnetic field intensity at any point. Okay. So what is the difference between electric field intensity and magnetic field intensity? So we had seen that if there is a charge, any charge, positive or negative, any charge placed in space, if it is stationary, it creates a electrostatic field surrounding it. Now if you move this charge, if you let this charge move at a constant rate, then it will create something called a static magnetic field. Okay, so the previous thing, E was a static electric field that we had seen. This is a static magnetic field which it will generate if it starts moving at a constant rate. So in the next lecture we'll be talking about Biot-Savart law. We'll solve some problems. We'll talk about Ampere's law. We'll solve some problems, and then I'll be giving you some exercise to solve. Okay, thank you.